It's good to be here. I am a professor at the University of Oklahoma. Oklahoma, like UT Austin and UT Arlington, is a research university, so I do research in experimental particle physics, and I know that's why you came here, because you really wanted to hear about that. So this is what I study. This will be on the quiz at the end, so take good notes, right? I study the fundamental particles of the universe. I am going to talk for about 45 minutes, then give you time for questions. So the universe is made of things called atoms. Atoms have at their core a nucleus. The nucleus is made of neutrons and protons are made of quarks. I spent about 20 years of my life studying how quarks fit together in neutrons and protons. I currently do my research at a laboratory called CERN laboratory, which is near Geneva, Switzerland. And the goal at CERN is to understand the structure of the universe. So suppose you wanted to know what a proton was made of, but you didn't have any tools to take a proton apart. Or let's take something more familiar. Suppose you wanted to know how a car was put together, and you didn't have any tools to take the car apart and look inside. What would you do? Well, what I would do is I would get the car going really, really fast, and I'd smash it against another car going really, really fast. You should probably do this with your parents' car, not your own car. And then it would break into smaller pieces, and you could see what it was made. So this is what we do at CERN. There is a tunnel that is 17 miles around, and in that tunnel we accelerate protons to nearly the speed of light so that we can smash them together. This is what the tunnel looks like underneath. The big blue magnets would bend the protons, and 40 million times a second, 24 hours a day, about 6 months of the year, 40 million times a second, we smash 100 trillion protons into 100 trillion protons to see what comes out. So here's another picture of that. Those are the two pipes that you can see. No, that's the screen. You won't be able to see it. So there's two pipes. Protons are going one way in one pipe and one way in the other pipe. And then every once in a while we bring them together. So there's like an artist picture of it. And we want to build a big detector, a big camera, to see what happens when the protons collide. So the detector I work at is called Atlas. It's about as high as a 10-story building, about half the size of a football field. You can see little people, right? There's people drawn right here. Okay? Yeah. So that's the size of the detector. It's gigantic, and when the particles smash together, they go flying through the detector. The detector takes pictures that look something like this, and from these kinds of pictures, we understand the structure of the universe. So yeah, I had to go to graduate school for 7 years and postdoc work for 7 years so I could interpret pictures like that, right? A child scribbling or something. But that's not what I'm going to talk about today, although that will be on the quiz at the end. What I'm going to talk about is this question. What does science have to say about God and the place of humans in the universe? All right? And you maybe have heard the story of what science has to say about God and the place of humans in the universe. It goes something like this. Once upon a time, humans used to think that they were pretty special. But then Copernicus came along, and he showed us that the Earth was not the center of the universe. The sun was the center of the solar system, and the Earth was just a planet orbiting, and that seemed to diminish the place of humans. Then Newton came along and said, the universe is just run by laws of nature. And so some people took that to mean that we don't need God. The laws of nature are good enough. They run the universe. And then Darwin came along and said, humans are nothing special. They're just the product of natural selection, a random mutation, kind of an accident of nature. And this is the story that a lot of people have heard about what science has to say about God and the place of humans in the universe. There's two problems with this story. The first problem is it's not true. It's just completely a fabrication. Now, it is true, if you look at this picture, this is a picture from Dante's Divine Comedy, or taken from that idea about what people thought the universe looked like. And it is true that the Earth is at the center. But the problem is that the closer you got to the center, the worse it got. In the middle of Earth was hell itself. And Earth was kind of like a garbage heap. Everything fell to Earth because it just collected the garbage from the universe. And so when Copernicus came along and said the Earth is not the center of the solar system, the center of the universe, instead it's just a planet, like all the other planets, it actually elevated the place of humans in the thinking of the day. So rather than demoting humans, it elevated them. But another problem with this story that we're often told is that it's old. Darwin's Origin of the Species was written in 1859. That was, before I was even born. That was a long time ago. And the real question is, what has modern physics told us about humans and God, the place of humans and God in the universe? So I want to talk about 4 pieces of evidence that tell us about God that we get from science. Now, this is not proof of God. You can't prove God from science. You can't prove anything in science. You can only disprove things. But this is evidence. And like if you've ever sat on a jury, I've had the privilege of sitting on a few juries, right? And you're fed evidence. And then you have to decide, what does the evidence point to? So I'm going to talk about 4 things: the origin of the universe, the design of the universe, something called the rare earth, and then the idea that mathematics describes the universe. So let's start with the origin of the universe. What has science learned about the origin of the universe? Well, we've learned that it seems that the universe actually had a beginning. This beginning is sometimes called the Big Bang. Actually, scientists use the term Big Bang in a bunch of different ways, and they usually don't define what they mean. But I'm going to use the term in its original meaning, which means the beginning of the universe. It was about 14 billion years ago, and it brought everything in the universe into existence. Before the Big Bang, there was no space or time or matter or energy. I mean, I can't imagine what it's like not to have space or time. You know, my body takes up more space than I'd like, so I understand space. I drove from Norman down to here, and it took more time often than you like because of the traffic. And so we're just bound to space and time. But it seems that space and time and matter and energy all came into existence. Now, 100 years ago, people thought that the universe was eternal, that it had always existed, and that it was infinite in size. But in 1929, Edwin Hubble discovered that the universe was expanding. And if the universe is expanding, it's kind of like, this is a picture of raisin bread, and the raisin bread can expand. And if the universe is expanding, then it must have started to expand. And so this actually implies that there's an origin. Now, scientists didn't like this idea that the universe had an origin. In 1931, 2 years after Hubble made his discovery, Arthur Eddington wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." Well, why is it repugnant that the universe might have had an origin, a beginning? Because if it might have had a beginning, it might have had a beginner. And that idea is repugnant to some scientists. But nevertheless, scientists have come to accept the Big Bang. Why? Because the evidence is overwhelming. There are 3 pieces of evidence that have convinced scientists that the universe had an origin. The first is that the expansion of the universe, like Hubble discovered. If the universe is expanding, it must have started to expand. The second is the amount of hydrogen and helium in the universe. So if you remember chemistry class, there's a periodic table. The 2 lightest elements are hydrogen and helium. And those were formed in the first 3 minutes after the Big Bang. And we can calculate how much hydrogen and helium we should see in the universe based on what we know about physics and chemistry and all. And what we get is exactly what we see in the universe. Our calculations match perfectly. And then the other thing is the temperature of the universe. So the Big Bang started out really hot. If you take everything in the universe and compress it to an infinitesimal size, it's really hot and it's really dense. And over 14 billion years, the universe has been expanding and cooling. But if it started out really hot, we should see some residual heat. It's kind of like, suppose you go home today and for some reason you have motivation to bake raisin bread. I don't know where you've heard raisin bread before. So you turn on your oven, and then after the oven gets really hot, you realize that you have no idea how to bake raisin bread, so you turn the oven off. Well, that heat from the oven is going to eventually dissipate throughout the house, and the whole house will be hotter because the heat was once concentrated in the oven. So if the universe started in a hot Big Bang, we should see the leftover heat, and we do. It's called the cosmic microwave background radiation. It was discovered in 1964, and it's exactly what you would expect if the universe had a beginning. So all the theoretical evidence, or all the experimental evidence says the universe had a beginning, but so does the theoretical evidence. In 1915, Albert Einstein developed what's called the general theory of relativity. It describes how gravity works. And in his theory, it predicted that the universe would be expanding. But this was before Hubble made his discovery, so Einstein didn't like that idea. So he added a fudge factor so that his equations would not have an expansion. He called it a cosmological constant. And it turns out that he later said that that was the worst mistake of his professional career. He should have predicted that the universe was expanding and had a beginning. In 1973, George Ellis, Roger Penrose, and Stephen Hawking took Einstein's ideas and they expanded them, and what they showed is that Einstein's general theory of relativity predicted that space and time actually had a beginning. And then in 2003, three physicists, Alexander Vilenkin, Alan Guth, and Arvind Borde, developed what we now call the BGV theorem, Borde, Guth, and Vilenkin. And it says any universe that's expanding on average had to have a beginning. So why do I say all this? Because it's pretty clear scientific understanding that the universe seemed to have a beginning. And if it had a beginning, it has implications. It means the cause of the universe can't be part of this universe. If this universe had a beginning, then the cause can't be part of the universe. It rules out certain views. It rules out a view of pantheism that says the universe is God, because this universe had a beginning. And so therefore, only worldviews that include a transcendent cause, a cause outside of the universe itself, agree with science. And of course, the God of the Bible is transcendent. So science seems to support a case for a transcendent creator. If the universe had a beginning, then it might have had a beginner. Now, this is not just a theologian's idea. Scientists have recognized this. Robert Jastrow, who is an agnostic scientist, when the evidence for the Big Bang became overwhelming, he said this about the implications. He wrote, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who've been sitting there for centuries." Right? Why? Because the theologians accepted the things that the Bible reveals that science discovered. One of the things is that the universe had a beginning. The very first sentence in the Bible says, "In the beginning, God created the heavens and the earth." Another thing is that the stuff of the universe didn't exist at one time. The writer to the Hebrews says, "We understand that the universe was formed at God's command so that what is seen is not made out of what was visible." We learned that when we understood the origin of the universe. And then finally, the Bible explicitly states that the Creator is not bound by space and time. Out of all the holy books in the world, only one explicitly talks about God acting before time. It's the writings of Paul in the New Testament. He says things like, "Grace was given us before the beginning of time." We didn't even know time had a beginning until 1973. But yet the Bible talks about God acting before the beginning of time. So the origin of the universe points to a transcendent God who is outside space and time. The next thing I want to talk about is the design in the universe. And I'm going to focus on something called the anthropic principle. The Greek word anthropos, which means humanity, and it's the idea that the universe seems to be designed for humans to exist, with lots of parameters finely tuned. A great book on this it's old now, the Anthropic Cosmological Principle, but it lists 100 such parameters. It's as if you have a control panel that controls the universe, and there's 100 knobs, and one of them might control the speed of light, and another one might control the mass of a quark in the proton or something. And if you change these knobs just a little bit one way or another, you either have no universe at all or a universe that's inhospitable to life. So since you got all afternoon, I got 100 parameters that I'm going to explain. All right? So, that's a joke. It might not be a joke. Anyway, so I'm going to just explain a few of them. The first one is the strength of the strong force. This is what I study in my research. The strong force is the force that holds quarks together in the neutrons and protons and holds neutrons and protons together in the nucleus. It's because of the strength of the strong force that we have the periodic table. And so if you like chemistry class and you like the periodic table, it's because of the strong force. If you don't like chemistry class, you can blame the strong force. But suppose I was to take the force, this force called the strong force, and I was to make it just 2% stronger. What would that do? Well, it would basically eliminate hydrogen from the periodic table. That would be bad. The sun burns hydrogen. Water is H2O. We'd have no water. Right? So that knob would turn 2% stronger, would make life impossible. Suppose we were to take the knob that controls the strong force and make it 5% weaker. The periodic table would then look like this. There would only be hydrogen. It would make chemistry class really easy. We'd all be signing up for chemistry class. But of course, no life. Another parameter that's finely tuned is the formation of carbon. So, as I said, in the first 3 minutes after the Big Bang, only hydrogen and helium were formed. So where do all the other elements of the periodic table come from? Things like carbon and silicon and oxygen. They all come from dying stars. Stars have a lifetime, and like everything in the universe, they're born, they live for a while, and they die. And one of the things that some stars do as they die is they create carbon through this very complex process called nuclear resonance states, which I won't describe because I don't want you to go to sleep. But there's been lots of research on how carbon is formed in stars. And one of the researchers at North Carolina State wrote this. He says, we find that more than a 2 or 3% change in the light quark mass. So what is that? Those are every neutron and proton has 3 quarks in it. We call them light quarks because their mass is relatively small. And this guy is saying if we just take the knob that controls the mass of those light quarks inside every neutron and proton, and if we change it 2 or 3%, what does that do? That leads to problems with the abundance of either carbon or oxygen in the universe. We basically wouldn't be here. All life is based on carbon. So that's finely tuned. Another thing is the amount of matter in the universe. So as the universe is born and starts to expand, everything is attracted to everything else by gravity. If there's too much stuff in the universe, the attraction is so strong that everything collapses back again. If there's too little stuff in the universe, it expands so quickly that galaxies and stars can't form because they're formed by gravity. And right after the universe was born, the amount of matter was finely tuned to 1 part in 10 to the 60th, a decimal point with 60 zeros and a 1. If you had changed the amount of matter by 1 part in 10 to the 60th, shortly after the Big Bang, we wouldn't be here. Paul Davies writes this, to choose rho, that's the Greek symbol rho, it's the amount of matter in the universe, so close to the critical amount, fine-tuned to such stunning accuracy, is surely one of the great mysteries of cosmology. If the crucial ratio had been 10 to the minus 57th rather than less than 10 to the minus 60th, the universe would not even exist, having collapsed to oblivion after just a few million years. Now, I gave a talk like this at Stanford once, and a physics professor came up to me and he said, you cannot use this as an argument for fine-tuning. You cannot use the amount of matter in the universe as an argument for fine-tuning. And I asked him why, although I knew what he was going to say. He said, because we think we know why the amount of matter is exactly what it is. There's a mechanism called cosmic inflation. In the very first 10 to the minus 30th seconds after the Big Bang, the universe seemed to expand really fast. This may be true, we're not totally sure, but if it did, it would force the amount of matter to be just right. So I began thinking, well, in order for cosmic inflation to work, you have to turn it on at just the right time, you have to give it just the right strength, and you have to turn it off at just the right time. And we have no idea how any of that works. If you have a mechanism that does exactly what you need to do, you haven't eliminated fine-tuning, you just moved it to a different place. An efficiently tuned mechanism exhibits design and fine-tuning. When I mow my lawn every other week, because I can't stand mowing it every week, I go to pour gasoline into the lawnmower, and it spills all over the place. So what do? I have a mechanism. It's called a funnel, and it forces the gasoline to go where I want it. Does that mean that because I have a mechanism that does it, there's no fine-tuning? Well, of course not. And so the mechanism of cosmic inflation does the job to give us exactly what we want in a finely tuned universe. And then finally, I want to talk about the entropy of the universe. Entropy, in kind of colloquial terms, is the amount of randomness or how organized something is. And the Big Bang wasn't a random explosion. It's a finely tuned creation event. Roger Penrose has calculated the initial entropy of the universe to be finely tuned to 1 part in 10 to the 10th raised to the 123rd power. Right? So this is the most ordered event you can imagine. Because in order for us to be here, in order for this universe to be here, the Big Bang could not have been some random explosion. It has to be a finely ordered creation event, which it was. So I've just mentioned a few things. There may be 100 of these. What do scientists say about this? Well, in their book, Cosmic Coincidences, John Grivet and Martin Rees write, if we modify the value of one of the fundamental constants, something invariably goes wrong, leading to a universe that is inhospitable to life as we know it. When we adjust a second constant, we turn another knob in an attempt to fix the problems. The result generally is to create 3 new problems for every one that we solve. The conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. So the universe looks like it's designed, maybe because there really is a designer behind it all. The next thing I want to talk about is the rare Earth. So in the Copernican principle, Earth seems to be just an average planet in an average place around an average star. But the question I want to ask is that true? What is required to have a planet that can support higher life forms? And by higher life forms, I don't mean things like people. I mean anything more complex than bacteria. Bacteria can thrive everywhere. There are extremophiles that live everywhere. But suppose you want something more complex. You want a world full of cockroaches, let's say, for some reason, okay? So what would it take to make such a world? Well, the first thing is you have to be in the right kind of galaxy. We live in a spiral galaxy. This is what our Milky Way galaxy would look like if you get far enough away from it. Only about 10% of the galaxies in the universe are spirals. The others are elliptical galaxies and irregular galaxies. And those galaxies don't have the right amount of star formation, or they have too much radiation, or other problems that would prohibit complex life. And you can't be anywhere in the galaxy. If you're too near the center, there's too much radiation. And right at the middle, there's a black hole, which is a terrible place to live. Unless you're in the movie Interstellar, then it's a good place to live. And if you're too far from the center, there's not enough star formation to make carbon and oxygen. So from about a third of the way out to 2/3 of the way out is what's called the galactic habitable zone. It's the part where you could actually have a planet that could be habitable, and of course our sun is right in the middle of the galactic habitable zone. The sun itself is quite remarkable. It's a class G star. It's probably the only kind of star that can have a planet like the Earth around it. There's some discussion of this, but it's also a third-generation star. The first-generation stars were only made of hydrogen and helium, and stars have a lifetime. Those stars were born, they lived, they died, and when they died, they made some carbon, some silicon, some oxygen, but not enough to actually form a planet like the Earth. So a second generation of stars formed from the debris of the first generation. And those eventually had a lifetime and exploded. And our sun took that material from the second generation of stars that exploded and coalesced into our sun. If you wanted to start with a big bang and make a star like our sun and planets like ours, the shortest amount of time it can take is 9 billion years. And that's when our sun was formed, about 9 billion years after the Big Bang. It's as if the earliest it could be formed, it actually was. There's other things about our sun. It's a bachelor star. It doesn't orbit any other stars. Most stars in the universe are binary stars that orbit each other. And that would mean that you can't have planets suitable for life because the gravity from this star would perturb the orbits of the planets in this star. The Earth has so many things about it that make it unique. You could list a whole talk with just the things about the Earth: its size, its density, its rotation rate, the amount of water, even tectonic activity, which causes earthquakes. I lived most of my life in California, and we have earthquakes. And you might ask, well, if God created a universe for humans, why would he make earthquakes that are so destructive? Well, it turns out without tectonic activity, you don't have a world with reasonable amounts of water and land. One of the major reasons we still have water on our planet and other planets don't is because we have tectonic activity. So if you want to make a planet that can support complex life, you need to have earthquakes. They're actually required if you want a planet with complex life. The moon and Jupiter play important roles. The moon stabilizes the tilt of the Earth. Jupiter is such a huge planet with such a huge gravitational field, it acts like a vacuum cleaner that sucks up comets and asteroids that are headed for the Earth to destroy life. In their book, Rare Earth, Peter Ward and Donald Brownlee write this: if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, if some godlike being wanted to make a planet like ours, our Garden of Eden is what he calls the Earth, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. Earth is not just some random planet, average planet in an average place around an average star. It is uniquely suitable for life to exist. And then finally, I want to talk about the mathematics that describes the universe. If you're an engineer and you want to build something, you do the math first. You make sure that the wings of the airplane will withstand the heat on them and that the structure will withstand the stress that it has. Well, math is the language of the universe. In physics, we say that we don't have a understanding of how the universe works until we can write a mathematical equation for it. If you can't write a mathematical equation for it, you don't yet understand the universe. So let me just show you a couple of those equations. I know you guys know this, so I don't want to bore you too much, right? But the bottom equation is Einstein's theory of general relativity. It's how gravity works. The top equation is the equation for the standard model of particles and fields. It's how all the fundamental particles in the universe works. This is the language of the universe. It looks like an intelligence behind it. It looks complex. In fact, Eugene Wigner wrote this. He says, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Right? This is a miracle that math describes it. Right? It says if there's an intelligence behind it all. But not only does math describe it, the universe is created. If you're an engineer and you write the math to build the plane, it doesn't build the plane. You need some power capable of actually building the plane to do it. And Stephen Hawking recognizes this in his book, A Brief History of Time. He says, even if there's only one possible unified theory, it's just a set of laws and equations, rules and equations. Suppose we know all the equations that describe the universe. But then he asks the question, what is it that breathes fire into the equations and makes the universe for them to describe? The usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Right? So the fact that not only does math describe it, which says there's an intelligence behind it, but it goes to the bother of existing. There's fire in the equations in Hawking's language. That means there's something out there capable of producing universes. So what do scientists say about all these things? Fred Hoyle writes this. Fred Hoyle, by the way, is an atheist. He writes a common sense interpretation of the facts. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. I don't know if you know the story of Antony Flew. Antony Flew was one of the biggest proponents of atheism in the 20th century. He spent his whole life defending atheism, writing about it, speaking about it, and at the age of 81, he changed his mind. He became someone who was a theist, believing in God, not necessarily a personal God. And he writes this. I mean, can you imagine spending your whole life defending one worldview, and then when you're almost ready to end your life, you realize, I was wrong. I've been wrong my whole life. And he writes this, I now believe that the universe was brought into existence by an infinite intelligence. I believe that this universe's intricate laws manifest what scientists have called the mind of God. This is the world picture as I see it, that has emerged, what? From modern science. So I've talked about a number of things, but if you think about it, these things originated a long time ago. The Big Bang originated in the 1930s, although we're still exploring it and studying it. The anthropic principle was developed in the 60s. We're still exploring it. And the rare earth was developed in the 90s. So, excuse me. The question is then, this is old. Has anything new come about? Because it's modern science. Well, the first thing to notice, is that in any good theory, if it's a good theory, that the more evidence you get, the stronger the theory becomes. I've been giving talks like these for 20 years or so now. And every one of these points, the evidence for it just keeps getting stronger and stronger. It doesn't get weaker, but as we discover more things, it gets stronger and stronger. Now, I'm a person that values truth. So I want to know the truth. So I look at these things and I say, well, I've given you one idea, one interpretation of these, that these things point to an intelligent, transcendent creator God. But other people look at the same evidence and they have other ideas. And so in order for me to understand truth, I read what other people write. If you look at who don't agree with me, if you look at my bookshelf, about a third of the books are by people who have a different opinion than I do. Here's some of the books I've read. So what I want to do in the last 10 or 15 minutes is I want to give you the alternative views. What do those who don't agree with me say? But I want to show you that I don't think those are as good understanding of the facts than if there is a God behind it all. So let's look at three of these things and ask, what do other people say about this evidence for God? First of all, let's look at the rare earth hypothesis. And there are a couple of proposals. One is that there are lots of planets, so there must be one suitable for life. And the other one that you hear a lot is, well, maybe there are other forms of life. The short response is there is little possibility of an Earth-like planet formed by chance, even in the whole universe. And the second one is that all life has to be carbon-based. So scientists like to do something we call back-of-the-envelope calculation. It's kind of an educated guess. So let's do a rough educated guess for the number of planets that might be like the Earth, that might support higher life forms. And we know what some of the things we need are. The planet has to be in a spiral galaxy, so that's a 10% probability. The star has to be the right distance from the center of the galaxy, so that's a 20% probability. Here's just a list. At the bottom we have tectonic activity. We really don't know how many planets have tectonic activity, so we guess, maybe 5%. We know none of the planets in our solar system do, except the Earth. So this is just a partial list of some of the things we need to have an Earth-like planet. And this is a little more complete list. Right? This list has 322 parameters that are needed for life to exist, for complex life to exist. And this list keeps getting bigger and bigger. I just don't want to remake this slide. But there's more things that are understood and discovered every year. And if you do the math, the probability for all 322 parameters occurring is 10 to the minus 304. There's at least 10 to the 22 planets in the visible universe. So we talk about the visible universe. It's the universe that we can see. The universe is probably much bigger than that, but all we can talk about is what we see. So the probability of finding one Earth-like planet formed by chance is 1 part in 10 to the minus 282. In science, we have a technical term for something that small. And the technical term is, it ain't going to happen. Right? So it's Stephen Hawking in his book, The Grand Design, makes just a statement. Well, there's lots of planets, so there must be a lot that have life. But here's the math. The math says that's not true. The math says that if you just want to make a planet by chance, like the Earth, it's not going to happen. Right? Even though there are a lot of planets. What about other life forms? If you watch things like the original Star Trek, you know that there are life forms like made of silicon, which is really just a man in a Horta costume, but that's another thing. So scientists can do the math. They can do the chemistry. They can ask, is it possible to have life based on any other element? One of the proposals is silicon, because silicon can't make long chains like carbon, but can make short chains. So there's a great paper written on the probability of finding any life based on silicon, and this was their conclusion. Carbon chemistry is the chemistry of life. Silicon chemistry is the chemistry of rocks. You try to do chemistry with silicon, you get rocks. If you want to make life in this universe, it has to be based on carbon. And therefore, the parameters, the necessary parameters, are very stringent because we know what carbon life is like. What about the origin of the universe? What do people who have a different view say about that? Well, again, I'm only going to give you two proposals. One proposal is that there was no beginning, and the second proposal is that the beginning was caused by the laws of physics. So my short response, and I'll go into a little more detail, is that for the first one, all known science supports a beginning. In other words, you could argue there's no beginning. Well, I'll get back to that. But everything we do know points to beginning. And then the second one, the laws are descriptive and still require an explanation. So let me talk about these a little bit. So first, it's important to realize what we do know from science. What we do know from science is that everything after about 10 to the minus 30 seconds after the Big Bang we understand. We understand the laws of physics. We can run computer simulations. What we don't know is what happened in the first 10 to the minus 30 seconds. And if inflation is true, we'll never know that. And so therefore, what you can do is you can do anything you want in the first 10 to the minus 30 seconds. If you don't want a beginning, you can say, well, there's things we don't know about it that would make no beginning. This is really appealing to ignorance. Everything we do know, point number 3 there, all the observations, all the calculations, all the theoretical things, everything we do know says that there was a beginning. The alternative proposals have no evidence. They require new physics to supersede what we know. they violate things we know are true, like the BGB theorem. And so it really is just wishful thinking to say there's no beginning, because everything we know looks like a beginning. If you want to hide in the first 10 to the minus 30 seconds and truthfully say, well, we don't really know for certain what happened, you're correct. But, if everything else after that looks like a beginning, and everything we do know looks like a beginning, then you're really hiding in your ignorance if you say anything else. In fact, Alexander Vilenkin, who was one of the authors of the BGB theorem, says this: with the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. So what if the laws of physics describe nature? What if the laws of physics brought the universe into existence? Well, then you have to ask, where do they come from? And Vilenkin says that. He says the description of the creation of the universe from nothing is given in terms of the laws of physics. That makes you wonder, where are these laws? If the laws describe the creation of the universe, that suggests they existed prior to the universe. The question that nobody has any idea how to address is where these laws come from and why these laws in particular. Well, some of us have some idea of where we think the laws came from, but Vilenkin doesn't acknowledge that, all right? So why do I do this? Why do I talk about all these things? Because I want you to understand that there are alternatives. I told you at the beginning there's no proof of God, but how good are the alternatives? Scientists go for the best explanation of all the facts. What's the best explanation based on what we know? And to understand that, you have to understand the alternatives. So let's do one more. What about the alternatives to design and fine-tuning? Oops, I skipped one. So there's really, again, two I'm going to talk about. One idea is that there are many universes, what we call multiverse. And the laws of physics are different in every multiverse. And we happen to live in the right one that supports life. And then the other idea is that it's just an illusion. There really is no fine-tuning. So the quick response to both these, then I'll go into some detail, is there's no evidence for a multiverse, and there are many multiverse models, and most still require fine-tuning. Actually, there is evidence for multiverse. It's called the Marvel movies. Because if we watch the Marvel movies, then we know there is a multiverse, but I hate to tell you that's fiction. All right, anyway. Yeah. All right, and then for fine-tuning, it's based on science. So let's ask this question. What if we did discover multiverse? Would that affect this evidence for the existence of God? Would that solve the problem? And the answer is, well, we don't know. Why? Because the ramifications of a multiverse depend on a confirmed mathematical model. There are lots of alternatives for multiverse. There's the string theory multiverse. There's the quantum mechanical multiverse. There's a bazillion different kinds of multiverses. We'd have to find out which one it is and write the mathematics before we could say anything. Oops. And only a few of the possible universes would still support life. So ours still looks pretty remarkable. And the laws of physics may require multiverse if there's to be complex life. So one multiverse model is called the string theory model. And it says that the universe is based on something called string theory, and that creates about 10 to the 500 different universes. So suppose you're God and you say, you know what? I want to make a planet with humans on it that I can have a relationship with on this planet Earth. And I got to build a universe, and let's build the universe based on string theory. Okay, that sounds good. Well, what do I have to do then to make a universe? Oh, I then have to make 10 to the 500 universes in order to have the one I want. All right, no big deal, I'm God, right? So it's possible that we discover a multiverse and it gives us further evidence for God. Because how many universes would an infinite God make? Right? So we don't really know what the ramifications are. Every time we discover something new in science, it gives further positive evidence for God. My speculation is if we ever discover multiverse, it's going to do exactly the same thing. Because that's been the track record. And then finally, the idea of fine-tuning is not just made up. It's in science. I love this book. There's a book by Geraint Lewis and Luke Barnes called A Fortunate Universe. And the reason this book is so good is that Geraint Lewis is an atheist and Luke Barnes is a Christian. And what they both agree is that the universe is finely tuned. That is incontrovertible. Luke Barnes says it's because there's a God. Geraint Lewis says we're just lucky we live in a multiverse. But this is what they say. The reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field of fine-tuning began in physics journals and remains with physicists. They go on to say, while there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. So what? So what if the universe is fine-tuned? So what if it had an origin? I love this quote by Paul Davies. Paul Davies is an agnostic. He doesn't believe in God, but he says this: if physics is the product of design, and it looks like it is, the universe must have a purpose. And get this, the evidence of modern physics suggests strongly to me that the purpose includes us. Isn't that a remarkable statement? The evidence of physics, of science, not, again, some religious book. The evidence from modern physics suggests that the universe has a purpose, and that purpose includes us humans. Now, again, this is an idea that comes from religion. It comes from the Bible. David, some 1900 years ago, or what, 2900 years ago, wrote the same thing. When I consider the heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you are mindful of him, and the Son of Man that you care for him? This is the same kind of thoughts that Hoyle has when he talks about a super intellect and who monkeys with the physics, and Davies' purpose that includes us. So when you look at all the data, all the scientific data, what is the best explanation? I think the best explanation, despite the alternatives, is that there is a transcendent, intelligent designer and creator who has a purpose for humanity. Now, there are scientists who have looked at this and agree with me. Alan Sandage was an atheistic scientist, and his study of nature eventually changed his mind. He became a Christian. He wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence." George Greenstein writes this: "As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency with a capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being?" Now again, I don't think you can prove God from science, so Greenstein is saying a stronger statement than I would say. But I would say that what we've discovered in modern science suggests, it gives abundant evidence that there is not just a deistic God, not just a God who started it all and left, but a transcendent, intelligent designer who created the universe, has a purpose for humanity, which is in exact agreement with the attributes of God described in the Bible. If you want some more information on this, I wrote a book. You can get it on Amazon. I used to write a blog. I stopped about 5 years ago because I ran out of ideas, but it's still out there. I have a YouTube channel, and we will open it up for questions. All right. Oh, right, before we do. Yes, I'll leave this up.
Thank you, Michael. All right, at your tables we have some pens. Take out your pens, get ready for the quiz. Are you ready? oh, wait, no. We don't have a quiz.
You would flunk the quiz.
We do want your feedback. Take a piece of paper there in front of you, looks like this, and fill it out. Tell us what you think about today's talk. If you want additional information, Mike did an article called 4 Reasons to Believe in God from Science. Check a mark on there, and we'll take care of you, and we'll get it covered. Mike spoke at the BSM at OU last night, but he says this is a much better crowd because everybody's going to fill out one of those forms and get them in. Right, Mike? My name is Nick Repak. I am the founder of Grad Resources. We're a faith-based service organization addressing personal, emotional, and spiritual needs of 3.2 million grad students in America. How many people here are grad students? Come on, there you go. Oh, there's one. Okay, make sure you come up and see me afterwards. I've got a Chick-fil-A card for you because I know you can't afford meals. So take time, fill out the card. Yeah, I know, grad students, right? Take time to fill out the cards. Mike, let's get you started on Q&A.
How do you want to do it? Oh, am I on? Yes. No questions are out of bounds. If we want to find out what is true, we have to be able to ask any questions. So I love all questions. Raise your hand. There's a mic. All right. And they'll come around.
So what's your take on the 7-day creation story in relation to this?
Yeah, so you have to first understand that the story of creation in Genesis is written in ancient Hebrew. So if you want to understand it, I work at CERN. Everybody speaks multiple languages. And what they tell me, like I have a friend who's German, he says, well, there's a saying in German which is really hard to convey in English. So if you really want to understand what the creation story is talking about, you have to study ancient Hebrew, which I haven't done, so I read the experts. And I learn a few things. I think the story is a true story, but I think that the days of creation are not 24 hours. I think they are long periods of time. The Hebrew word yom, which is translated day, actually has a meaning of a long period of time, just like English. If I say in the day of the dinosaur, the Tyrannosaurus rex was a fearsome predator or something like that, day means 24 hours, or day means a period of time. And so I believe that the 6 days of creation are long periods of time, and then those days fit in perfectly with what we know about the history of the universe. And again, my understanding of the meaning of the word yom as a long period of time comes from the best Hebrew scholars. It's not my original idea. And this is also covered in this book. Some of the things about why I believe how the story of the days of creation align with the Big Bang. That's the short answer. There's a lot longer answers. Yes. Other questions?
So what's your thoughts about the big bounce? Or like the bounce theory, where like the universe...
Yeah, so when the Big Bang was first proposed, the idea that was floated was that the universe will expand and contract, and therefore you still have an infinite universe. There are many problems with that. Basically, no one accepts it anymore. One of the reasons is you can do the calculation of what would happen to the entropy. And every time you get a bounce, you gain entropy. So even if there were bounces, we would be in one of the earliest bounces, is what you learn. But beyond that, what we've learned since the 1930s, when the Big Bang was proposed, is there's this thing called dark energy. And dark energy is causing the universe to expand more rapidly. And there's not enough mass in the universe to cause the expansion to stop and contract. So, I talked to some scientists about this who study this, and I say, so there's no possibility of a contraction. And again, their hope is that the universe didn't have a beginning. So the scientist's answer was, well, maybe the dark energy will change its sign, and instead of causing things to accelerate, it'll pull things together. So he's wishing for something to happen that's not going to happen, right? But yeah, so the dark energy basically means that this universe will never collapse. There are no bounces. Yeah. Over here.
Do you believe in evolution as a process? Are you a theistic evolutionist?
What do you mean by evolution?
By specifically creature, like human beings, are they like Darwinistic evolutionism as a process?
Yeah. So Christians have lots of views on how God created humans that are all possibly true biblically. I have real problems with the current mechanisms of evolution. The current mechanism of evolution is that random mutation and natural selection will cause small changes, which eventually lead to big changes. The reason I ask you what you mean by evolution is if you go into a biology class about evolution and they show you evidence for microevolution, that is the evidence for big changes. Macroevolution, so people who do believe in evolution don't distinguish macro from micro. Macro is just micro over time. So when people who don't believe in evolution start making this distinction, you're talking two different languages. So if evolution is small changes over time, yeah, bacteria becomes resistant to antibiotics. That's evolution. If evolution is we're all related through the tree of life and it all happened through small microscopic or small changes that accumulate over time, I have problems with that. I don't have problems from a biblical viewpoint. If I go to the Bible and say, could God have used evolution, I can point to lots of reasons why I think he could have. But as a scientist, I have real problems with evolution. In my field of physics, we only prove something is true unless there's a 1 in 6 million chance we're wrong. So I'll talk to other Christians who believe in evolution, who are geneticists and biologists, and I'll say, here's my problem with evolution. The mechanisms don't work. You can't give me a 1 in 6 million probability that everything that you're saying is right. But in my field, that's what it takes. And what they say to me is, well, your standard is too high. In biology, we don't use a standard of 1 in 6 million that you're wrong. And I say, yeah, but I'm a physicist. So I struggle with the current theory of evolution from a scientific viewpoint because I don't think it works in the way it claims to work. I don't have a problem with it from a biblical viewpoint. That's a whole nother story. So there's 3 categories. Young Earth creationists, well, there's 4. Young Earth creationists don't believe in the Big Bang or evolution. Old Earth creationists believe God used the Big Bang, but are skeptical that God used evolution. That's where I stand. Evolutionary creationists believe God used the Big Bang and evolution. There are a lot of great Christians who fall in that category. And then a naturalist would say there is no God, so they're kind of a 4th category. Does that help? Good. Yes.
So in the future, if we come up with a unified theory of everything or something, we unify quantum mechanics and gravity, then do we still need God to explain the universe?
Yeah, again, the mathematics itself, to me, indicates there's a design behind it. And the mathematics itself doesn't create the universe. The mathematics describes the universe. It's prescriptive. It's descriptive, not prescriptive. It describes how things work. It doesn't cause them to work. And so, to me, every time you discover a better understand the universe, a unified theory, if you have one, I'll co-author the paper with you, right? But if you discover it, you haven't removed God. That's the God of the gaps argument. These are not God of the gaps arguments. I'm not saying we don't understand it, therefore God must have done it. I'm saying we do understand it. And it looks a lot like it's designed with a purpose from what we do understand. So to me, a unified theory doesn't take away God. It just describes the laws of physics that are created by the Creator. So yeah, I mean, I'm a good scientist. I loved a unified theory. It would help us in our work, but it doesn't. Finding how God did it through the laws of physics doesn't necessarily remove God. That's the God of the gaps. That's a Greek idea of God. We don't know why thunder works, so that Thor, the god of thunder, must cause it. That's not the biblical idea of God. The biblical idea of God is he created the universe to work and to show what he's like, but not because he necessarily causes, well, you got to be careful with terminology, not because he constantly intervenes within the laws of physics, but because he created the laws of physics. Yes, and then you had one up here, right? Do you still have a question? Yeah, no, all right.
I was gonna ask real quick if the world is fine-tuned to support human life, then I think it's fair to assume that maybe humans and a relationship with man was God's end goal for all of this. Having that aside, if you don't believe in a young Earth and you think that the Earth is actually millions or billions of years old, why do you think God waited for those billions of years without communing with man until
Well, how long did he wait in eternity before he created? How long is 14 billion years to a timeless God? Right? Yeah, I think that Romans writes that since the creation, God's invisible attributes are clearly seen through what has been made. I think that the fact that the universe is so big and that it takes that time, that the laws of physics work, give glory to God. Again, he had eternity before he made this universe, and is 6 days any different to a timeless God than 14 billion years? Moses writes with the God of days as 1,000 years and 1,000 years as a day. He doesn't keep time like us. It's no big deal. That's how I look at it. Good question, though. I mean, these are important questions. Because I do believe, you're asking questions about the Bible and God's motives, and I do believe the Bible is God's word. So I do believe it's true in what it talks about. And so when there's an apparent contradiction, we have to discuss that and see what the best resolution is. And I think the best resolution is kind of what I've talked about, that the days are long periods of time. I think that's clear within the Hebrew text and other things like that. Again, I may be wrong. I have pastors in my church who are young earth creationists. I have pastors in my church who are old earth creationists. We believe the Bible is true. We both have reasons why we think our understanding of that story is best, but it's a non-issue. It's a peripheral issue that we discuss. All right, other questions? Yes?
It has to do with fine-tuning and specifically about the rare earth
Yes.
argument you presented. The first objection you brought, that we would expect a place where all these multiple parameters would be in such a way that life would exist. And I can imagine an atheist saying, well, because the universe is so huge, it would be natural to assume that at one particular point in the universe, those parameters would match to produce life. So we just don't need God because there are so many other points where it does not exist. So why is it surprising that at one particular point it does exist?
Yeah, I think there are a few answers to that. First of all, it's a partial list. The list keeps growing. The math was done by a guy who understands correlations and all. So when you say there's a 1 in 282, 1 in 10 to the 282 probability of finding a planet like the Earth, in order to have a 1 in 1 probability, the universe has to be 10 to the 282 times bigger than it is. Well, that's possible because we don't know how big it is. So that's why I reserved my comments to the visible universe. But again, we're talking odds and probability. If there's a God, every planet could have life. So what I'm saying in that is these are the odds by chance, given the best information we have. So the best information we have in the visible universe is a 1 in 10 to the 282 probability. And actually the number gets smaller because there's more parameters that keep coming in. But you're right. If the universe is 10 to the 282 times bigger than what we can observe, then the probability is 1. And we happen to be the one planet in the right place. And again, these are possibilities. This is an important principle. I don't base my life on possibilities. If I did, I'd play the lottery and I'd gamble, right? And I do neither one. I base my life on probabilities. You know, it's possible that we live in a matrix and this is all an illusion. It's possible that when I drive back to Norman, some guy is going to be drunk and cross the line and going to smash my car, I'm going to die. But the probability is that this is real, it's not a matrix. The probability is that most drivers probably are sober enough to drive. And I base my life on probabilities. You can always come up with a possibility to explain all this. We might be, in a matrix. We might be a computer simulation. Who knows? But the question you have to ask yourself is what explanation gives the best explanation for all the facts, not just a small number of them, and is therefore most probable. And that's what I decide, that's how I base what truth is, because that's the best I can do. But that's a great question, because yeah, you're right, there's always options. We may, there's always options, but are they the best option to explain the evidence? Other questions?
You've mentioned some big numbers so far. Could you help us understand? Oh, right, I'm back here.
Yeah.
I'm back here.
Oh, yeah.
Could you help
Ben.
us give us a comparison of like when we say 10 to the 282, like for instance, how many atoms are there in the universe?
Yeah, I don't know these numbers off the top of my head. People always do this kind of thing, like you pile dimes to the unit, to the Earth, to the moon, and you pick the right dime out. And I have never done those things. So I will tell you that there in a book I had in a book on statistical mechanics, it's a class you take as a physics major, there was a problem in the back of the book called the meaning of never. And the meaning of never, the problem was if you had, 100 monkeys typing on 100 typewriters for the age of the universe, would they ever type Hamlet? And the probability is like 1 in 10 to the 100,000 power or something. So even though the probability is not 0, the author says, this is never. It's never going to happen. So that's my joke, right? 1 in 10 to the 282 ain't going to happen. But someday I'll have to figure out how many dimes you could stack up and how high it'd be to pick out the right dime for that number, right? Yeah. But again, these are, the other thing is, I'm a physicist, so I take these numbers somewhat with a grain of salt. Is the number exactly 10 to the 282? No. It's a back-of-the-envelope calculation. It's an extremely small number. And so it's not precise enough to figure out how many dimes I need. Yes. You had a question? Yes.
So my concern is the people that make the objection to the probability causing us instead. So what is your reasoning to know that, hey, the probability, because it led up to this, is the reason we're even created in the first place, instead of us being the reason the probability takes place? If that
I
question
don't
makes
know that
sense.
I understand your question.
Um,
Is there another
like-
way to phrase it?
So you said like the mass probability, like 10 to the power of like,
Whatever.
negative, yeah, whatever. So if it was just slightly different, would something else take place that would have created something else, and then that life form would
Right.
have had the same idea as us?
Yeah, so, again, that so some of these things, that's a question that deserves an answer. For some things, it isn't. For instance, many of these parameters that are finely tuned, there would be no universe at all. If you change the amount of matter at the beginning, there's no universe. So it doesn't matter what comes out the end. There's no universe. And so for some of the things, you could ask that. But that's also why I talked about, could there be other life forms? And the answer is not in this universe. Now, you might want to design a universe with a completely different set of laws and physics and periodic table. But given what we know about this universe, these parameters are not just us making them because we're us, but they're true in the whole universe, based on this universe and the laws of physics of this universe. Does that make sense? Yeah. Good. I don't want to keep you off noon. By the way, if you have to go, go. I teach a class of 300. I'm never offended when they all walk out. All right, so, yes.
All right, so this is an excellent sermon and everything, but it seems like science is trying to catch up to God. Do you think science will ever be able to catch up to God?
Yeah, that's a good question. I'm not sure I would put it that way. I would go back to what Paul wrote in Romans 1. Paul writes that we should see the character of God in creation. I'm not trying to force creation to give me evidence for God. I'm taking the Bible at its word, that when I look at God's creation, I should see aspects of what he's like. And so I'm not trying to make science catch up with God as much as I'm trying to elaborate with some scientific expertise on what we know should be true if we believe the Bible's true. That by looking at nature, we should see things about God. All right, we've one more, and then I'll let you go, and I'll stick around. If you still have questions, you can come up and talk to me in person. But let's do one more, and then, is that good, Ben? Yeah. Good, all right.
What is the statistical probability of never? What's that benchmark?
That's a good question, and scientists don't have an official one. Colloquially, we'll use 1 in 10 to the 50th or 1 in 10 to the 100. So if you get to that number, most people will call that pretty much never. But there's no formal never. All right, thank you again for coming. Oh, one more question. All right, sorry.
Yeah, I'd just like to circle back to the 6-day creation.
Yeah.
So on that, I looked up Yom, and it is used plenty of times in the Bible. Sometimes it is used for long periods of times. What I found is that when it's used paired with a number, it usually indicates the regular 24-hour.
No, that's what the Young Creation says. It's not true. Look up Hosea 6:1 and 6:3, and look up Zephaniah 14 or Zechariah 14. In both cases, you have the word yom with a numeral, and it doesn't mean 24 hours. So many of the talking points of young earth creationism can be shown to be false from the Bible itself. And that is one of the talking points that can be shown to be false. In fact, when I studied this for myself, that was one of the things that changed my mind, is I went and looked at the talking points the young earth creationists say, and then I went and found in the Bible where there were counterexamples. And so what they said wasn't true.
Does it also not say there was morning and there was evening?
Yeah, and so who wrote Genesis 1?
Moses.
And what else did Moses write other than Genesis 1?
Exodus, Leviticus, Numbers.
Other than the Pentateuch. Psalm 90. And in Psalm 90, Moses uses those very same words, evening and morning. They're the Hebrew words Arab and Boker. He uses them metaphorically to mean beginning and ending. And when I studied this for myself, I asked, why would the Holy Spirit inspire Moses to write one other thing other than the Pentateuch, Psalm 90, and in that psalm clearly use the exact same Hebrew words metaphorically to mean beginning and ending? Because that's what they can mean. And the Holy Spirit is showing us that that's how Moses uses those words. We do it in English. If I say the dawn of a new era, I'm saying the beginning. If I say the twilight of your life, I'm saying the ending. And not only can Arab and Boker, the Hebrew words, mean beginning and ending, but Moses uses those words to mean beginning and ending, not literal morning and evening in Psalm 90. Yeah. Good question. Oh, we've got another one. All right. Well, yeah, you guys can leave. I'll keep going. Yeah, go ahead.
Have you done any debates with atheists?
No. I have never done a debate with atheists. I think debates can be worthwhile if they're under the right circumstances. I would certainly be willing to do it. Texas A&M gives out a prize called the Trotter Prize. It's for people who do work in science and philosophy or science and religion. I was awarded that prize 2 years ago, and the person that won it with me was Sean Carroll, who is an atheistic physicist. So we gave talks where he supported his view of the universe and I supported mine, but it wasn't a formal debate. But in that forum, the atheist and the believer both shared their view of the universe to the same audience. All right, thanks for coming. Ben has a few things to say.